That's correct, Juanito. Congratulations. We will move on to the third question. For $1,000, what is the name of the effect of a stimuli trigger that causes an increase in the magnitude of the membrane potential? A. Depolarization. B. Hyperpolarization. C. Combo club. Or D. Threshold.
You know, this one time, I had an out-of-body experience when supernatural beings talked to me. I need a snack. Having some milk. Where am I?
Oh, you're awake. You're in heaven.
Am I dead?
No, you're just unconscious. But since you're here, I will grant you one question. You can ask whatever you want. So think carefully.
Well, what's the secret of life?
I didn't say I'd answer your question. I'm just kidding. What was your question? The secret of life, yes. Well, most humans would like to know the answer to this, and I will tell you. The secret of life is action potential.
Action potential?
Yes. The secret of life, see, is the ability to think and move. And how do you suppose you do that? Through signals in the nervous system. And how do we make these signals? With action potential. But I'm not the resident expert on the nervous system, so I will have my friend, Professor Daniel, explain it to you. Oh, well, thank you, God. I would love to explain action potentials. Action potentials are the signals we are referring to when we talk about the nervous system. But how do they work? Well, just imagine the membrane of a neuron. Entrenched in the membrane are two types of gates through which sodium and potassium can pass. There are activation gates, which open to let the ions travel across the membrane, altering the membrane potential. A rise in the membrane potential is called a hyperpolarization, while a fall in the membrane potential is called a depolarization. It is when a stimulus causes the sodium channels to open that the action potential process begins. When the activation gates on sodium channels are opened, sodium is allowed to pass through the membrane and into the neuron, creating a depolarization. The charge inside of the neuron then becomes more positive. This increases the membrane charge and causes the membrane to approach a threshold, initiating the action potential. Depolarization opens more gates on the sodium channels while leaving gates on the potassium channels closed. When the voltage increases enough, a signal is sent through the axon. After the signal is sent, hyperpolarization begins to occur. Activation gates on the sodium channels begin to close, blocking more sodium from entering the neuron, while activation gates on the potassium channels open. This allows for potassium ions to leave the neuron, lowering its charge. Once enough potassium has exited the neuron, it will return to its resting potential, readying it for another action potential. Now all of this craziness happens within 1 or 2 milliseconds, which allows for signals to be sent at a very, very high rate. This explains how we're able to do things so quickly, like that, and like thinking and stuff. And that's the secret of life. Back to you, God. And that, Juanito, is the secret of life.
Ah, dude. Jorge, what the heck, man?
Hey.
Why'd you hit me with a fish?
I want to eat the fish for dinner. I need to tender it up. I have one of those tender hammer things, so I thought I'd just use your head.
Dude, you have a strange resemblance to God.
What are you talking about? I think you hit your head pretty hard there, Juanito.
I'm gonna have to go with B, hyperpolarization.
That is correct, Juanito. Now, for $5,000. What is a clever metaphor for communication between neurons? A. Protons and neutrons. B. Oceans and fishies. C. Fruits and veggies. Or D. Cars and streets.
It's a tough one. It's a tough one. You can use my lifeline. I'd like to phone a friend.
Alright. So Juanito's gonna phone a friend. What's the name of your friend, Juanito?
Jorge.
Jorge. Alright, let's get Jorge on the line.
Hello?
Jorge?
Hey, Juanito.
Yo, man. What's up, Jorge? Alright, okay. Jorge, what is a clever metaphor for communication between neurons? A. Protons and neutrons. B. Oceans and fishies. C. Fruits and vegetables. Or D. Cars and streets.
Man, don't you remember we were talking about this that one time? It was around like Christmas time one year. Dude, do you know what I just realized? Alright. Cars and streets are like a clever metaphor for intercommunication between neurons. Alright, so basically we have the metaphor. The house in the background is the cell body, which is basically the whole neuron. It has the nucleus, and it sends out messages, and that's what we're seeing here. And so this is basically the axon. The whole street is the axon, and the cell body will send that message, bio is cool, to the other neuron through the axon, which is the car in the street. The car is what's actually sending the message, but the street is the myelin sheath, which protects the neuron. And it will keep going and going and going and going until it gets to the other neuron, to the dendrites, which are tentacle-like things that will receive the message and send it to the cell body. And that happens at the synapse. And there we go.
That's Jorge. Cars and streets, D. Final answer.